Okay, here we go. So bit sad, last session on matrices today, although it's a bit of a shorter one. Now, recently we've been looking at transformations, how you can use matrices to transform one point to another. And this session is all about when you've got more than one transformation. So you're maybe reflecting it in the x-axis and then rotating it, and what matrix would be used that would do that in one go. Okay, so let's go straight in with an example. It's probably easier to look at it from an example. So EG1, we're going to look at two examples today. So EG1, point L is transformed to point N by matrix 1, 2, 0, 3, and then point M is transformed to point N by matrix 0, minus 1, 2, 1. Okay. These will do some sort of transformation. Now the question is, what is the single matrix that would transform point L to point N? Okay, so how do we go directly from L to N and not have to do that intermediary step? Okay, now you can just multiply the matrices together. So you multiply matrices together, but order matters. The order, how you multiply them is very, very important. So the order matters, and it's the last. So the last transformation goes first. Okay, so in this example, because your second transformation is 0, minus 1, 2, 1, that comes before the first transformation, 1, 2, 0, 3. It must be in that way. So this is the second transformation, that was the first. So it works from like inside out, a little bit counterintuitive. If we were to multiply those together, a little bit of practice on multiplication of matrices, 0 times 1, add minus 1 times 0. 0. Top right's going to be 0 times 2, which is 0. Add minus 1 times 3, negative 3. Bottom left, 2 times 1. Add 1 times 0, 2. Bottom right, 2 times 2, which is 4. Add 1 times 3, which is 7. So that would be our answer. That is the matrix that combines, that takes point L directly to point N without that intermediary step. Right, let's look at another example, EG2. Okay, the unit square is transformed by matrix 0, minus 1, 1, 0, followed by 1, 0, 0, minus 1. Okay, the unit square is that matrix followed by that matrix. Find the combined transformation matrix and describe it. Okay, so find the combined transformation matrix and describe it. Right, so we've got to get the order right first for the combined. So the second one, which was that one, this one goes first, followed by the first one. That was the second transformation, that was the first one. And if we multiply those together, we get 1, 0, 0 times 1. Top left is 0, top right. 1 times minus 1 is minus 1 times 0, minus 1. Bottom left is 0 times 0, minus 1. And bottom right, 0, 0. Okay, just check you can do that. So that's the combined matrix. Now we need to describe it. So to describe it, if we look back at the last session, it's where does my original unit square, which is 1, 0, 0, 1. Now that first point, so 1, 0, 0, 1, goes to 0, minus 1, minus 1, 0. So that first point tracks onto 0, minus 1. So let's put, so that point there becomes 0, minus 1. So that point goes to there. And the other point, I'll make it maybe that colour, that point, so this point goes to minus 1, 0. So that point goes to minus 1, 0. Now I've got to just think, what is the transformation that moves that point to that point? And you'll see that it is a reflection in the line. So this is the answer for the description. So 0, minus 1 is the combined transformation, which is a reflection in the line y equals minus x, and that would be my answer there. Okay, so this is really a powerful tool where you can move lots of coordinates. It's used a lot in computing, computer gaming, when you're moving one point to another. It's how graphics are moved around on computers really effectively. Okay, so I want you to have a go at a few questions now. So it's page 249, exercise 9D, and I just want you to do the evens, please. So the evens, so question 2 to question 10 goes on to page 250. Okay, and that is the end of matrices on Further Maths course, and we'll be moving on to some trigonometry and stuff next time. So well done, guys. See you then.